Hello students, today we are going to learn the topic polynomial. Let's start with some basics. An algebraic expression is a combination of numbers, letters representing variables, and symbols used for mathematical operations. The key components of an algebraic expression include coefficients, variables, terms, and constants. For example, in the expression 4x plus 2, 4 is the coefficient, x is the variable, and 2 is the constant. Now, what is a polynomial? A polynomial is a mathematical expression made up of numbers and variables like 3x plus 2. It's a versatile tool used in math and science to describe relationships and solve various real-world problems. Next, let's talk about the degree of a polynomial. The degree of a polynomial is the highest power of the variable, like the 2 in x square. It's a way to describe how big or complex a polynomial is in terms of its variables. For example, in the polynomial p of x equals to a 3x cubed plus a 2x2 plus a 1x plus a 0, the degree is determined by the highest exponent present. Moving on, if p of x is a polynomial in x, and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x equals k. For example, let's take p of x equals x square plus 2. If we substitute minus 4 for x, we can calculate p of minus 4 equal to minus 4 square plus 2, which equals 16 plus 2, giving us 18. Now let's look at the types of polynomials. A monomial is a polynomial with just one term. For example, 2x, 6x square and 9xy are all monomials. A binomial is a polynomial with two unlike terms, such as 4x square plus x or 5x plus 4. Lastly, a trinomial is a polynomial with three unlike terms, such as x square plus 3x plus 4. Next, let's identify the type of polynomials given below based on their degree. For the polynomial 2y plus 6, the highest power of y is 1, so it is a linear polynomial. In the case of root 2 plus y square plus y, the highest power of y is 2, making it a quadratic polynomial. Finally, for y cube plus 4, y square plus 2y plus 1, the highest power of y is 3. So it is a cubic polynomial. Now what about the zero of a polynomial? The zeros of a polynomial are the x coordinates of the points where the graph of the polynomial intersects the x-axis. A quadratic polynomial can have either two distinct zeros, two equal zeros, 1 0, or no zeros, depending on the shape of its graph. A cubic polynomial can have at most 3 zeros. To understand this better, let's discuss the geometrical meaning of the zeros of a polynomial. For example, if we plot the graph of the linear polynomial y equals 2x plus 3, we can observe the point where this line intersects the x-axis. That point represents the zero of the polynomial. If 3 is a zero of the polynomial, p of x equals 2x square plus 3x minus 9a, then find the value of a. If 3 is a zero of the polynomial, p of x equals 2x square plus 3x minus 9a, then p of 3 equals 0. Now p of x equals 2x square plus 3x minus 9a. Substituting x as 3, we get p of 3 equals 2 times 3 square plus 3 times 3 minus 9a. Simplifying step by step. P of 3 equals 2 times 9 plus 3 times 3 minus 9a. P of 3 equals 18 plus 9 minus 9a. Now we equate p of 3 to 0. 18 plus 9 minus 9a equals 0. 27 minus 9a equals 0. Solving for a, 27 equals 9a, a equals 3. Therefore, the value of a is 3. Now, let's consider a question about graphs. Which of the following is not the graph of a cubic polynomial? Among the choices given, option D is not the graph of a cubic polynomial. It is a graph of a quadratic polynomial, as the graph is in the shape of a parabola which opens downwards. Let's dive into the relationship between zeros and coefficients of a polynomial. The sum of the zeros of a quadratic polynomial ax square plus bx plus c is equal to minus b divided by a, and the product of the zeros is equal to c divided by a. Similarly, for a cubic polynomial ax cube plus bx square plus cx plus d, the sum of the zeros is equal to minus b divided by a, and the product of the zeros is equal to minus d divided by a. Here is the relationship between zeros and coefficients of a polynomial. The given quadratic equation is 2x square minus 3x plus k. If one zero of the equation is reciprocal to the other, then let one zero be alpha and the other zero will be 1 by alpha. We know that the product of zeros alpha beta equals to c divided by alpha is equal to the constant term divided by the coefficient of x square. This gives the equation alpha into 1 by alpha equals c divided by a equals to k by 2. Solving for k, we get k equals to 2. In conclusion, we have covered the basics of polynomials, their types, the concept of zeros, and important relationships between zeros and coefficients. Understanding these fundamentals will help you solve various polynomial problems confidently. We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 10. Thank you.